We are at the technical faculty where the studies of the study field program take place. The building was renovated in 2014. It's equipped with auditoriums, laboratories, a library, and other study spaces. The infrastructure of building is also adapted for students with disabilities. There are spaces for students to relax and communicate in the students' rest zone. Meetings with the Erasmus Plus participants graduates are organized in Art of State Cinema Hall, as well as project presentations. Conferences, career days, meetings, discussions, and festive events take place in the Assembly Hall. A modern gym is equipped for students' needs where students physically develop sports skills and strengthen their health, as well as participate in group trainings with professional coaches. In the spacious premises of the college library, students can study independently and lecturers can prepare for their lectures and improve their professional competencies. Students and lecturers can access the electronic resource subscribed by the college library from computers in the college reading auditorium or online. The college is a member of Lithuanian Research Library Consortium and participates in the project of this organization, opening of the online research databases for Lithuania. The library subscribes to 3 international databases: EBSCO Publishing, Taylor and Francis Online Library, Emerald Management e-journals collection. The latest information provided in the databases helps to perform various tasks, deepen knowledge independently, and achieve the study result for a study curriculum. The college library subscribes to electronic books published by Vilnius Gediminas Technical University Publishing House Technica and Kaunas Technical University Publishing House Technologija. Most of these books are in Lithuania. The Vilnius College of Technologies and Design virtual library is being created through the system of Lithuanian Academic Electronic Library ELABA. The library contains methodological instruction for the course papers, self-study tasks, and final thesis of the study program. 209A, 209B, Physics Laboratory. The physics laboratory is designed to develop students' experimental skills for work with the modern experimental equipment, to provide knowledge about methods of measuring physical quantities, processing of experimental results, their computer modeling, presentation and evaluation of measurement errors. Students perform practical works in various fields of physics: mechanics, acoustics, molecular physics, and thermodynamics, electromagnetism, and optics. Some works are designed by a computer in a virtual environment, increasing the variations of various physical actions, expanding the boundaries of tasks. 011. Mechanics Laboratory. In the Mechanics Laboratory, students apply theoretical knowledge of mechanics. The Model for Performance of Experience of Physics, MECA number 1, has been used for static experiments of non-deformable body, and Model MECA number 2 has been used for performance of laboratory works of dynamics. Using the tech equipment, a set of experiments for machine elements, students analyze efficiency of belt, chain, worm, cylindrical pinion, and conical pinion gears. The laboratory contains various other equipment: pinions, slip frictions, stands, Audi A6 mechanical gearbox stand, and other. 102. Electrical Engineering Laboratory. In the Electrical Engineering Laboratory, students deepen their theoretical knowledge of electrical engineering. Using specialized equipment and measuring devices, they practically check the laws of electrical engineering, analyze DC and AC circuits, as well as operating modes of electrical circuits. 108. Electronics Laboratory. Theoretical knowledge of electronics is applied in the practice performing laboratory works using technical equipment. Using the laboratory stands of linear electrical circuits, students gain knowledge about the main electronic elements: diodes, transistors, operational amplifiers, get acquainted with their parameters, learn to measure their characteristics, form and study the following units of elements: rectifiers, amplifiers, harmonic vibration generators, study the signal forms using the digital oscilloscope, determine the causes of faults in the circuits.
107. Microcontrollers Laboratory. Practical works in programming, power electronics, basics of automation and robotics are carried out in laboratory of microprocessors. MATLAB and Arduino Robot Studio software are used for the work. Students program in C, C++ languages. The developed programmable logic controller stands introduce students to Siemens S7200 programmable logic controllers and the Step 7 Micro Windows version 4.0 SP5 software package. During laboratory works, students program logic controllers using a variety of programming languages, such as functional block diagrams, contact diagrams, structures text. 151. Electrical Machinery Laboratory. Modular Electrical Machine Test Stands Technical Training and Education EM3000 and Unitrain are used to study the subject of electrical machines and drives. Students learn to connect, start and control DC and AC motors, measure the parameters of electrical machines, design electric drives. In the laboratory, students perform experimental work with electric motors, simulate motor operating modes, and compare the obtained characteristics. 152. Electrical Equipment Laboratory. Practical works, final projects layouts, interdisciplinary and experimental development projects have been carried out in the laboratory. Specialized electrical equipment installation stands, final project layouts have been used for implementation of practical works. In the laboratory, which is equipped with the up-to-date equipment and follows the European Union standards, students apply innovative technical solutions and implement them in the production of experimental development products. In the part of laboratory dedicated to design work, students, using the software, design printed circuit PCB boards and draw detailed drawing of parts. Prototypes of parts printed in 3D printers are used to produce various projects. The practical work forms an advanced approach of future specialists to the application of modern electrical equipment. 001. Pneumatic Laboratory. In the Pneumatic Laboratory, which was equipped following the latest requirements, students using the Lucas Nulla stands acquired the basic knowledge of pneumatic systems. Festo Step Controller FPC 101 has been used as an interface module and combines electronic control with pneumatic actuators. During practical work activities, students acquire knowledge about the function of the main components and basic circuits and their control. Later, they apply the knowledge of electrically operated pneumatics field and skills of operation and analysis. During classes, students assemble, disassemble, and model modules and systems, thus gaining the ability to plan and organize works and evaluate the obtained results. 101. Automation and Mechatronics Laboratory. The industrial robot KUKA Agilus Kia 3 has been installed in the laboratory, and it is used by students to acquire theoretical and practical knowledge about the robot design, operational principles, programming. Students work with specialized robot programming and control software package KUKA or Fishlight and the robot operation simulation software package KUKA Sim. The water level control stand allows students to get acquainted with the automation object common in the industry, the structure of the system, the principle of operation and control features. Students analyze various object characteristics, system response to setting change, system readjustment, control error while changing and adjusting digital proportionally integrated differential control parameters. The temperature control stand is used to introduce students to the controllers and sensors used in temperature control and maintenance systems. Students work with the several different closed-type regulators that are used in the industry to solve temperature maintenance and control issues. Programmable logic controllers, PID controllers, relay contact control, industrial sensors, and frequency drive stands are used for practical work. 103. Electrical Network Laboratory. The Turco Energy System Simulator installed in the laboratory helps students to better understand the work of the energy system and the interaction of its separate units. Models of various voltage lines and transformers are installed on the stand, fully reproduce the image of the Lithuanian energy system. Installed smart electronic device, which correspond to the devices used in the power substations of the Lithuanian power system, enable to create relay, protection and automation of the electricity network. Normal and emergency electricity network modes are simulated by means of a simulator. Both students and lecturers' scientific research and experiments in the field of electrical network are based on simulators operation. 104. Building Management System Laboratory. The subjects of building management systems and management information systems are studied in this laboratory. Students carry out practical works with stands of building automation system, KNX, security systems, information cables, multi-apartment fiber optic network.